guys, here is the rest of 12-4. I want you to look really well at number 6 here. Is my vertex in, on, or out? Well, it is outside that circle. Now, the way this problem was meant to be is that these lines would be tangent. And I know that because when I look at the answers they gave you, this problem is something that you could do if you had tangents. However, in this case, I do not. And you can't solve it unless these are tangents. So technically, number 6 is impossible to do. So I'm hoping that you will just eliminate that from your repertoire. So take number 6 out. When I looked at it, I didn't realize that they weren't tangents. If they were tangents, it's a doable problem. But however, in this situation, it's just not. So let's just throw number 6 out. Looking at number 7, though, we have a circular cabinet in the dining room. So here's my cabinet. It's a circle. You're looking from another room. So outside of the kitchen, outside of the dining room. Remember, this is my dining room. And this is the outside. So I'm sitting here and I'm looking in at this cabinet from point A. You want to be able to, that we can see an arc of the cabinet here that's 100 degrees. And that's what's marked. They want you to be able to figure out what is this angle that I'm at. Now, this isn't really a problem you're ever going to really, I'm sorry, I wasn't even looking at the whole problem when I was highlighting for you. So I underlined that this came from the dining room cabinet, that I'm looking, here I am, a person, and when I look, I'm estimating I see 100 degrees of the cabinet, and they want to know what is that angle. When I'm doing this problem, I can't imagine a real-life application where you would have to do this, but for the sake of argument, we're just going to kind of roll with it. First thing we have to figure out is what is this angle, or this arc right here. I'm looking for another color so that I'm not using the same one. What is this arc first? I have to be able to figure that out. Now notice, unlike number 6 up here where I don't have tangents, I can't calculate what x is. But here, this is a whole circle. I've covered the whole thing. I know this whole circle is 360 degrees. So if the red part is 100, what is left over for the green part? Well, this is 360 degrees minus 100 degrees, which is 260. So now I have a measurement for that large arc, and I can do the problem. I know that I take the large arc, and I subtract the small arc. Then I divide that in half. And that's going to tell me what this angle x is in the question right here. So 260 minus 100 is 160. And 160 divided in half is 80. And that's what angle x is. So I hope the problem seems a little simpler once we work it out. Looking down here at number 8, it's a little bit tougher. You have to think back to what did we talk about when a diameter intersects a chord, because right here this is a chord, and right here this is a diameter. The chord goes this way, and the diameter goes here, and notice that we have a 90-degree angle. That tells me something. When they do that, I know this is bisecting, that these are bisected. They are the same length. Very important, because that doesn't just bisect that. This arc is the same length. It also bisects this arc. So this arc is the same length as that arc. So right now I know that Z is 120 degrees. That was a very simple question, wasn't it? But look right here. I can figure out, looking at this whole thing, or looking at one at a time, we can figure out some different things. This line, if I take it out, let me highlight it in red. If we pretend like this red line isn't here, we have a pretty simple problem. We know that this whole arc is how big? 120 plus 120, or 240 degrees. Notice that when I go all the rest of the way around, we've now covered the entire circle. So this green arc right here is 360 degrees minus the 240 degrees we know. That leaves us with what? 80 degrees. Oh, I lied, 120. I was doing it the wrong way. Sorry guys, 120 degrees. So if this green arc is 120 degrees, can I find this angle altogether? Well, I can. I take the big arc, 240. I subtract the small arc of 120, divide it in half, and that's going to tell me this big angle right here, whatever y plus x is, because together that's yx. I'm not going to separate it yet. 240 minus 120, I'm a little afraid to do my math in my head right now, is 120, divided in half, is 60. Now, this is that arc. That arc right there is 60, the whole thing altogether. They don't want to know what the whole thing is. They want to know what y is and what x is. But because this diameter is bisecting that and these guys are chords, then I know that these two angles have to be the same. You could use trig if you wanted to, but there's really no reason to do that. At this point, I think angles are just a much easier way to do it. They're congruent triangles, so we can just bisect 60. Each of them have to be the same, so 60 divided by 2 is 30. So y is 30 and x is 30 as well. I hope that problem helps you as you're thinking about some of these other problems you're going to be running into. Looking at this. Interesting, right? I'm looking here and I see that that angle right there is 38. I see this angle is 18. Not really super helpful, except that notice that this vertex of this angle is inscribed on that arc. And I know that is 34. So the intercepted arc is twice that angle. So 34 times 2 is 68. Now I look over here. Notice this is an inscribed angle. They tell me that angle is 18, which means that this arc is 2 times 18, which is 36. So now I can do the problem, and I think all of you could do it at that point. Remember, we take the big arc, we subtract the small arc, divide by 2, and that gives me the angle. Hopefully you all can work that out. And I love this problem. Tangents are one of my favorite things to work with. I just think they're fun. I'm kind of probably sick about all that, but it is fun to me to do that. It is a little bit of a tricky problem. They tell me a lot of things here in this problem. One, I love tangents because I know those guys are congruent. I know these guys are congruent. I know these guys are congruent. And it's just kind of a nice problem. I love tangents. They're also telling me here that these two arcs that this arc and this arc, we don't know if they're the same because these guys are not necessarily the same. So we can't make any assumptions here. But I do know that this is a tangent. And I know that that's x degrees. Can I find this whole piece? Sure. It's 360 minus whatever that is. So right there I can find what this whole thing is. So I know that 42 degrees is going to equal, well, what is this big arc? I'm going to put it in parentheses. It's the whole circle minus whatever that is. So that's the measure of that arc. Then we're going to subtract the small arc, which is just an x, and we divide by 2. Because we have all of the same variables in that same problem, it's pretty easy to solve. First of all, 360 minus x minus x. Well, I can drop my parentheses now because there's no multiplication going on, and a minus x gives me a negative 2x. So now I'm going to subtract 360 on both sides. Oh wait, I got to divide by 2. So I have to multiply the whole thing by 2. 2 times 42 is 84. Now we subtract the 360. I jumped the gun there. That's not negative. So 84 minus 360 equals, oh, I can't remember how to do that. Is negative 276, and that equals negative 2x. Divide by a negative 2, and I know that x equals 138. So I know that this arc right here is 138. So in this case, x equals 138. Now, because these two angles are congruent, I know this triangle here, I'm going to color it green, is what? Don't think about the circle inside. Think about what kind of a triangle that has to be with base angles congruent. Yes, it is an isosceles triangle. And as an isosceles triangle, I know that I'm going to have some congruent stuff going on. So I know this arc is going to be congruent to that arc. So I take whatever that's left over, I can find out what this whole arc right here is from y, this piece right here. I can find that. I take 360 and subtract my red arc. So 360 minus 138 tells me that that arc, hang on, 360 minus 138 equals 222. 222 cut in half because of the isosceles triangle tells me that y is going to equal to 111 and z is going to equal 111. So I hope that helps you realize how to do those problems. I want you to take a shot here. Oh, you can't do 11 because we haven't covered that yet. But I think you can do 12. Remember, the radius can be drawn anywhere. I didn't do a good job on that radius because I didn't want to cut off the 8. 8 is probably talking about 8 is this. This is 10, and that's 12. You know what? You can't do that one. As I'm looking at the answer, they're not wanting you to find it. So no 11 and 12. And 13 is going to be out too. We're going to talk about those next class. But I think you can do 14. I think you can do 15 and 16. Now this is an expression. You may struggle with these because what they're wanting you to do is use x. They want you to find x by itself. So you have to set up each equation. So I know, forget that these, we would say angle y would equal the big arc x minus z over 2. Remember, that's the letter z. And then they want you to get x by itself. That's what this is asking for. So how do I isolate that? Well, I would have 2y would equal x minus z. I would add a z to both sides. So x equals